The KNN algorithm, or the K nearest neighbors algorithm, is an algorithm that's commonly used when it comes to solving classification problems. So what we're going to be using the KNN for is for classifying whether a stock is a dividend paying stock or not based on a number of attributes. So we're going to be seeing how we can set up the KNN algorithm in Python and how we can use it to determine our appropriate classification for this problem.
So let's have a look at how we can use the KNN or K nearest neighbors algorithm to determine whether a stock pays a dividend or not. So here we're using the same data set that we used originally to run our logistic regression, and we're going to use the KNN to see how the performance compares. So the first thing we're going to do is import all of our libraries. So we have the standard ones: NumPy, Stats Models, Pandas, Scikit-learn, etc. And one library that we're importing here is min-max scaler, because we want to normalize our data in order to be able to allow the KNN to interpret it properly. And we're also importing the kneighbors classifier from scikit-learn. So let's go ahead and import those. And what we'll now do is set up our file path and import our variables. So again, we're using pandas to read in the variables from our CSV file. So we have our dividend variable as our dependent variable, i.e. 1 if it pays the dividend, 0 if it doesn't. We have our free cash flow per share. We have our earnings growth. And our debt to equity variable. So we're setting dividend as our y variable, and we're stacking our independent variables under x, so free cash flow per share, earnings growth, and debt to equity. So we've imported our variables in here. And what we want to do is we want to scale our x variable so that the KNN can interpret it properly. So we're using min-max scaler to transform the value of x based on minimum maximum normalization. And when we run our x scaled, you can see that we generate values between 0 and 1. And what we will do is we will define our training and test data for both x and y. So again, we're running the model, generating the model based on training data, and then we're validating it using test data. So let's go ahead and generate the KNN model itself. So we want to print out the shapes of both the X training data and Y training data, as well as the test data for X and the test data for Y. And let's set up the KNN. We're setting the number of nearest neighbors to 1, so we're running a simple KNN model here. And we want to come up with a test set score when we run the KNN algorithm. So you can see that we have a test set score of 0.72 here. And if we go ahead and visualize the KNN plot, we're using the mglearn library that we imported. And you can see that this is our plot visualization. So we can see that we have our training classes and our test predictions, and the KNN is indicating the distance between these two. So we've seen that we've gotten a test set score of 0.72 with one nearest neighbor. Now, let's see what happens if we introduce more nearest neighbors into our model. How is the test set score going to change? So let's increase this from 1 to 3, for example. So we're going to go for 3 nearest neighbors here. And when we generate a test set score, we see it's increased slightly to 0.78. And when we plot our KNN once again, we see that it's updated to account for the fact that we now have 3 nearest neighbors here. And again, let's update it to 10 and see what we come up with. Still, we come up with a score of 0.78. And our plot also updates to account for 10 nearest neighbors. Let's now try 15. And when we run it for 15, you can see our test set score has shot up to 0.9, and our plot adjusts to account for 15 nearest neighbors. Let's now try 20. And you'll see that our test set score has decreased slightly to 0.85. So there's no exact science to it, but roughly we can say that 15 nearest neighbors has been an ideal number of neighbors for the KNN model. And generally, we don't want to have too many nearest neighbors, because anything above 20 means that the model is not going to perform as well. But we've seen that by setting the number of nearest neighbors to 15, we have gotten a high test set score for our model. So you've seen in this tutorial how we can use KNN to solve classification problems, and how we can adjust the number of nearest neighbors to improve the accuracy of our model.